What are some of the unique challenges to trying to develop a supersonic business jet?
Well, we've taken a very traditional approach and staying with very conventional design with regard to materials, construction techniques, flight controls. We're using an existing engine with the JT8D-219 engine. So it's really quite conventional, and we've tried to design out any areas that would impose risk in the program. So other than the fact that we're going 1.6 Mach, it's a very conventional airplane.
What are some of those tests that have been going on at Dryden?
Well, we're validating some of the test points with the airplane up to Mach 2. We will follow up with an actual facsimile of the wing scale model underneath the F-15, which will give us some additional data. One of the things that allows us to do is to get live data as opposed to a wind tunnel that does impose some noise that doesn't give you the same degree of accuracy as you might get in a subsonic tunnel.
Talk to us about where you are in the overall project. Is it something that you're looking at you might actually be flying in X number of years?
Well, the program is a 5-year program once we start a hard launch. The next major phase will be engaging an OEM as a partner, and then from that time it'll be a 5-year program to market. I don't expect that under these conditions we're going to announce an OEM for probably at least a year. So that would be about a 2016 introduction when the time comes. A lot of that's dependent on the conditions of the market and an OEM's ability to participate and finance a $3 billion program.
When you talk about using some conventional materials, it's actually a very conventional airplane. Are you looking at composite construction, or are you using a more conventional material? What's the airplane made of?
Well, the wing will be made of carbon fiber, and that's required for both stiffness and strength. Part of the design incorporates natural laminar flow characteristics, so you need to require the smoothness of the wing throughout the flight envelope. So that's why we'll be using carbon fiber. Our assumptions are that we will build the fuselage out of conventional metal. We've limited the speed to 1.6 Mach, and we're going to be flying below 51,000 feet. So that allows us to use conventional construction techniques in the design.
Is that a price consideration, or is it actually better material for what you're doing?
Well, it's material that works for what we're doing, and in some cases it's a price consideration. It may be that in some cases we may use carbon fiber in the fuselage. We haven't made that decision yet, and that will be influenced by the OEM as well.
What kind of interest are you getting from the marketplace in the airplane?
Well, we started taking orders 3 years ago. We established a $4 billion order book, and that was prior to going into the recession. We've been able to retain that order book, and that says something with regard to the level of interest in the airplane itself. There are a lot of manufacturers that would be very envious to have that experience. So I think it does speak well for the interest in the airplane.
Brian Behrens from Aerion, thanks very much for taking some time with us to talk on Aero TV.
It's a pleasure. Thank you.
Integra Release 9 sets a new standard with the easiest to use pilot interface in all of general aviation. Access to any of Release 9's powerful capabilities is as simple as pressing the desired bidirectional page key. Pressing the same key in a desired direction navigates to the clearly labeled tabs with no more guessing as to what a given pilot input would do. Avidyne's Integra Release 9 is the next generation in fully integrated flight deck technology, and the easiest to use page and tab user interface is just one of the many benefits designed to make your flying easier and safer.